This is a model of our pilot plant. We use this depot for the project O-CEI Pilot number 3. It's a typical Austrian Post depot with around 60 cars. 58 of them are already battery electric vehicles. We have a solar plant on the roof, and right now the delivery guys are coming at around 3 to 4 p.m. in the afternoon back from their route. They come with the cars, plug it in, and all the cars who are plugged in just start their charging process until they are 100% full. And right now there is no optimization in the charging process.
The idea of this pilot is to try optimize this charging procedure. So choose when to charge them and how to spread out the charging, when to buy power from the grid, when to use the solar panels, when to sell power back to the grid in order to optimize the entire cost over the next week, month, year, and so on. So to start, for each day, when the vehicles arrive, we find what the price of the power will be for that day and the price for the power for the next day, which is given as well. So now here we can see, for example, for one day, how the price of the power will be for this day and for the next day. And these red lines are, this first line is when all the vehicles arrive, and this red line is the next morning at 6 a.m. when they leave. So sometime in this window, we want to try to optimize the charging. Now we can see, of course, at some period, the price is expensive, and at other period, it's cheaper. So of course, we want to try and charge the vehicles more in this period when it's cheaper here and less when it's expensive. So currently, the strategy is as soon as a vehicle arrives, we start charging and charging until they're full. So the distribution of total power looks something like this. But this kind of coincides with when the prices are more expensive, as well as the total peak power consumed is quite high. And the price that we pay is a combination of charging, the price of the power while we're charging, plus also the higher the peak, we pay a fee for a high peak. So we have a few ideas how to optimize this. So now if we look at this plot, on this plot we have the current strategy of the power that we use, and this is our optimal strategy where we charge when the price is the cheapest while trying to lower the peak. So as the price goes up, we don't charge, we only charge when the power is the cheapest. And when we compare this traditional strategy to our new strategy, for one day for this depot, currently we'll save around 50 euros. Now this is a small depot with 60 vehicles, and for one day if we're saving 50 euros or 60, 70 depending on the distribution of the power, over a year this can be many tens of thousands of euros, 10, 20,000 euros for one small depot. So if we extrapolate this to the entire post of 6,000 vehicles, this can be 100 times bigger saving. Now this is just the first approach, just from moving when we're charging each vehicles. In the future, we'll add some prediction to see maybe the price for tomorrow or the next day will be cheaper or more expensive, and then we'll charge more or less today based on the future prices. And additionally, maybe if today is expensive and tomorrow is cheap and then expensive, we'll buy power, sell back to the grid when it's more expensive, use the solar panels to charge the vehicles, or sell to the grid based on the price of the power in order to optimize the total cost of the energy to the post.